The applications that demand deep learning range from self-driving cars to healthcare. But the way that models are developed and trained is similar regardless of the domain. A model is trained in the cloud and deployed to a device. The device engages with the real world, gathering more data. That data is sent back to the cloud where it can improve the model, and the cycle continues. From the processor level to the software frameworks at the top of the stack, the impact of deep learning is so significant that it is driving changes everywhere. At the hardware level, new chips are being designed to perform the matrix calculations at the heart of a neural net. At the software level, programmers are empowered by new frameworks like Neon and TensorFlow. In between the programmer and the hardware, middleware can transform software models into representations that can execute on hardware with improved performance. Milena Marinova is the Senior Director of AI Solutions at the Intel AI Products Group, and she joins the show today to talk about modern applications of machine learning and how those translate into Intel's business strategy around hardware, software, and cloud. It was a real pleasure talking to Milena because we were able to go from the top of the stack down pretty deep into the weeds, and it was fascinating to get a description for how Intel is planning to take advantage of this massive platform shift that's taking place in technology. Milena is attending the O'Reilly AI conference, which is hosted by Intel, Nirvana, and O'Reilly, September 18th through 20th, and you can contact her directly or stop by the Intel Nirvana booth to learn more about what Intel is doing in AI. Full disclosure, Intel is a sponsor of Software Engineering Daily. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/sedaily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/sedaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. Milena Marinova is the Senior Director of AI Solutions at Intel AI Products Group. Milena, welcome to Software Engineering Daily.
Thank you. Pleasure to be here.
Today we're talking about deep learning and the implications of deep learning and machine learning and AI for Intel. And I know that many people think of Intel as a processor company, a hardware company, and my sense is that the company is becoming a superset of those things. It's expanding into more areas and looking at how those new areas affect its traditional hardware businesses. So I want to get into all those different things, but first let's talk about the driving force behind a lot of this, which is deep learning. And I think, I've asked many people for a definition of deep learning, and I've gotten different answers from different people, and I think that's fine because it's a wide-ranging term and it means different things to different people. But I'd love to start off by just asking you what your definition of deep learning is.
Sure. Going back in academia and some other kind of classic book type of definitions, and we won't cover all of them, but deep learning is a subset of machine learning. And deep learning essentially is a neural network approach to learning from data and then acting on data. And the part about deep is that there are more than one hidden layers in that neural network. And if you'd like, we can go into further descriptions and taxonomy.
Please do.
So, machine learning is the classic approach to analyzing data, and it's a collection of statistical models that train on some data, and then the so-called inferencing or performance on new data is being measured through a validation to see how accurate these models are. Within machine learning, neural networks were developed to mimic the human brain and each neuron, how we do anything based on the signals we get from different neurons. And each neuron in an artificial neural network essentially has a weight that activates and responds to what problem you're trying to solve and how you're training that neural network. And so, furthermore, the deep neural network has more than one hidden layers of these neurons, and there could be varied structures and different compositions of parameters in the neural networks. And so this is where things get pretty complex, but I'll leave it at that as kind of an overall deep learning definition.
No, I think that's great. And I think people who want more high level definition for deep learning, they can certainly go into the back catalog of Software Engineering Daily. We've done so many shows about this. But continuing on this thread of your perspective, what role does reinforcement learning play in deep learning systems?
Well, reinforcement learning, again, back to classic AI, also has been around for a while, just as deep learning, and is another subset of AI. And if you think of the Venn diagrams, the machine learning has deep learning entirely within machine learning space. And then reinforcement learning has some overlap, but not entirely. So deep reinforcement learning is this new space where we're solving new problems, where we're combining deep learning and learning from data, and we're combining different policy function optimizations. It's found in autonomous driving, in robotics applications, anywhere that you would want to have feedback from the environment and you have autonomous machines taking action in that space.
Now, is labeled data a requirement for deep learning systems?
Well, labeled data is certainly very important to train networks that need to classify certain things, like for imaging, the standard image classification approaches. It would be very difficult to really extract value without the labeled data. Recently, we have some advances that allow us to work without labeled data. So the generative adversarial networks you probably have heard have come to be super popular, generating data artificially. So it's used again for training neural networks, and that's where you can generate the type of data you want without having to go through the cumbersome labeling process. So for faces, in face recognition or other types of synthetic data used for training, the GANs have proven quite helpful.
How did those work? Because that's actually a topic we've not covered at all. So at a high level, how does a generative adversarial
At a
network
high level,
work?
there are really two networks, the generator and the discriminator, which is the adversarial. And the generator tries to get really better and better at generating the synthetic data that the discriminator is trying to gauge whether it's real or synthetic. And then as the generator becomes much better and could almost fool the discriminator, that's where you get really great performance. And still, you need some real data to be able to do so, but not as much as other types of deep neural networks.
I actually heard a great episode of a different podcast called Data Skeptic on it was the entire podcast was on this topic of generative adversarial networks, and I'll put the link to that podcast in the show notes. I do think it's fair to say that most neural networks today are ones that work with labeled data, and the labeled data is, like you said, super important to training and I guess benchmarking the ongoing effectiveness of the neural network. What do these modern data labeling pipelines look like? How do people get large volumes of labeled data?
Well, this is a whole section of there's a lot of innovation in each step of the process, right? There's innovation happening into the data augmentation and loading of data and labeling of data. There's innovation happening in the hyperparameter optimization space and trying to automate some of that. There's innovation happening in which types of neural networks to choose, right? The so-called composite neural network structures, and especially when you get into the concept of multimodality, when you have speech and imaging and various other components being used in whatever problem you're solving. So innovation is happening everywhere. For the pipeline of data labeling, there are neural networks created just for the sake of accurate labeling and trying to automate some of that human supervised job. And so humans end up kind of just reinforcing whether the network was correct in labeling or not. So I think that's probably the most advanced approaches that I've seen in the pipeline of training neural networks to even label the data and segment objects and kind of improve some of the labor associated.
I looked at this presentation that you gave in preparation for our show today. You gave a presentation at AI Berlin. I will put that presentation in the show notes. One of the slides from that presentation had these growth trajectories of the effectiveness of image recognition and speech recognition, and you examined just how much deep learning impacted the progress of these two fields, of image recognition and speech recognition. And it was pretty incredible to see how sharply image recognition improved and speech recognition both improved due to deep learning. But the performance gains have tapered off, and it seems like we're not hitting that low-hanging fruit anymore. Why is that? Why have we hit this point of diminishing returns for neural networks or deep learning to improve image recognition and speech recognition?
Well, if you look at the numbers, the quest was to get better than humans, right? So we're already, with image recognition, we're already over 98%, and speech is nearing the 99% of what humans are doing. And then the deep neural networks are getting better than humans. So naturally, that leaves less room for improvement, especially when we jump from much higher error rates for the machines using the classic previous machine learning approaches. So I think it's probably less important to get further gains, although I believe there's a lot of room for improvement. For example, combining speech recognition with voice identification and knowing your voice speaking to Siri or Alexa or Cortana versus somebody else's voice, that's not quite there yet. So we have opportunity, but I think we've already surpassed the human abilities quite substantially, and we're in minuscule error rates. So I would like to see people focus on other areas where deep neural networks can serve as problem-solving tools.
At this point, we've talked abstractly about deep learning and some of the applications for it. And I think you were just mentioning some problem-solving tools. I guess before we get into deep learning systems, because I want to talk about putting deep learning systems into production and what people are doing there, can you just elaborate a little bit more on that last thing that you just said, the areas that you're looking forward to people applying deep learning to?
Well, Jeff, I'm very excited about deep neural networks, and I think that's what the community is kind of looking for as a problem-solving tool. The deep neural networks allow us a general framework that's incredibly powerful, and it is so because we don't have to orchestrate these ensembles of machine learning algorithms anymore, and that's the shift of how we're addressing problems, from choosing the exact features and parameters and variables to analyze data. We're now choosing the structure of a model, the topology, the parameters, so that the neural network can discover the right features in the data and extract meaning. So in many ways, humans are meaning-making machines in psychology and from the beginning of what we can remember. And so uncovering meaning through the deep neural networks in these problems that surpass the human ability to do so, that we're not very good at it, dealing with arithmetic or perfect recall and perfect memory. We just have things that the human brain is not that great at. And so the deep neural networks can approach problems like those where we're actually somewhat good, but our capacity is still limited, and dealing with huge amounts of data can certainly help in various types of problem areas.
Cloudflare runs 10% of the internet, boosting the performance and security of millions of websites. Many of you probably already use Cloudflare on your sites, but we're not talking about using Cloudflare today. We're talking about building on top of it. If you're a developer, you can build apps which can be installed by the millions of sites which rely on Cloudflare. You can even sell your apps. They can make you money every month. Your users can log in or register to your service inside your app. They can get a real-time preview of your tool live on their site, and they can start paying you monthly, all from within Cloudflare apps. They can go from never having heard of you or your service to having it installed on their site and paying you in seconds. Visit cloudflare.com/sedaily to watch how you can build and deploy an app in less than 3 minutes. That's cloudflare.com/sedaily. Thank you to Cloudflare for being a new sponsor of Software Engineering Daily. I completely agree. It seems like to a deep learning engineer, every problem looks like a nail and it feels like you've got a hammer. And I think that might actually be the reality. It's like, or maybe that's a bad analogy, but this tool is so flexible and it's so useful. And I think that's why there's so much attention being put into this space. But of course, some problems are easier to frame in terms of deep learning than others. I think image recognition and speech recognition are these two areas where we've seen these massive gains, in part because it's really easy to understand how to frame the problem and how to put these problems in terms of deep learning. That might not be so obvious in terms of, like that Google Smart Response thing. Like, it's not perfect, right? Like deep learning can't write my email for me quite yet, partially because we're not sure like how to do that. I mean, we just don't know how to frame the problem correctly. But let's talk about people who are framing the problems well enough and putting deep learning systems into production today. Why don't you give an overview for the prototypical deep learning system that is being put into production? What does the architecture look like, and maybe what are some of the strengths and weaknesses of these systems?
Well, that's an excellent question, Jeff, because it's still fairly early and the space is very fragmented and it's quite complex, right? You see people spending time on software and frameworks, companies doing a lot of innovation in hardware. There are tons of startup activities doing hardware innovation. Intel is doing a lot of things, both in hardware and software. And I think that's where we're trying to approach this in a very holistic systems level, because the complexities, I don't want to underestimate. These are not simple solutions and they're not simple things to deploy, right? The deep neural networks are fairly complex and they're still designed by humans to solve specific problems that humans have. And from a systems level, it's very important to have a hardware framework with the software and the tools to make people focus really on the problem and deploying the right structures of the neural networks that will help them solve the problem, as opposed to dealing with data cleaning and incompatibility and optimizations and all the fragmentation out there. So I think Intel is really working hard to help kind of drive the system level approach and still be open. We're working with all the popular frameworks. We're working with actually different types of hardware even, including competitors. So we're trying to approach this at the system level, and I'm very happy about that.
Okay, so what are some of the shortcomings? What are the areas where, let's say, software can help, or specific areas where hardware can help?
Well, hardware really helps when it becomes a question of compute, right, and time for training. So we're still spending, I think, the mind share of the space dictates at least 70%, if not more, on the training. Because if you don't design and train a deep neural network correctly, you're not going to get any benefit from deploying it for inferencing or working in the real world. So training is a big focus area. And so clearly hardware helps a lot. And you don't want to sit around for weeks and days waiting for your neural networks to train. And that's where Intel is making a big push into the custom hardware being developed for really highly scalable and high performance linear algebra computations, lots of matrix multiplications, lots of specific deep learning designed linear algebra chip work is being done with the Intel Nirvana. And that really has an impact. But for the average enterprise, they're not going to overhaul their entire infrastructure and go and buy hardware before they have figured out where the business value comes, right? And I go back to what is the problem being solved, and defining that problem and being able to calculate impact and real business value, then will justify the huge investments in hardware. And I think that's where the software solutions and some of the startups and some of the things we're doing on my team with emerging solutions, looking for where algorithmically you can develop new custom neural networks and you can find value and solve a real problem. And then that will kind of imply the full system deployment and will justify the investments required.
So let's talk a little bit more about the hardware. I think you're not exactly a hardware expert, and I'm certainly not either. Maybe you can tell me either like what changes you need to make at the hardware level, because I know Intel is making custom ASICs for deep learning, or if that's not the area that you really have a perspective on, maybe you could tell me where your domain expertise lies and maybe how you are like what it takes to interface with hardware engineers about these custom ASICs. So like for the reason that what motivates this question is I did a show with your colleague Will Constable, and that show I had to prepare a lot for because we were talking about distributed deep learning, and I very quickly got out of my comfort zone, and we barely got to a discussion of hardware. We were just talking about like distributed systems, software problems, and I imagine that it reaches the limits of anybody's comfort zone quite quickly, even without hardware. So I guess this is a long-winded question. It's not a very good question, but I'm just wondering what you need to know, or kind of what your perspective is on the hardware-software interface.
Well, as you pointed out, it's a very complex problem, and certainly Will knows a lot more about distributed algorithms than I do. But I go back to this concept of a system solution, right? So you're not going to drive. So Intel's working on, as you said, lots of accelerators, lots of ASICs. Why is that important? Because the operations are different. So for deep learning specifically, you're doing essentially lots of linear algebra. And that's the design of the Intel Nirvana chip is designed to do matrix multiplications and parallel multiplications to speed up the training and to speed up the operation. But that in and of itself, for certain customers, of course, like Google and Facebook and Amazon means a lot because they have massive expertise and huge pool of talent in AI space. But for other customers in this global world of being impacted, as a sidebar, every industry is being impacted by developments in deep learning and other AI approaches. So the data scientists and the consumers of that technology need tools to help them solve their problems and need a full stack of software and frameworks and tools. And this is where some of those customers are not going to care immediately about the hardware. And I think we don't even know some of the hardware demands of the future. I mean, for example, with deep reinforcement learning and simply reinforcement learning, we have an indication that the standard CPU architecture is doing quite well, right? That custom linear algebra chip is not probably the best for reinforcement learning training. We don't have good benchmarks yet on what deep reinforcement learning algorithms demand from the future compute when we have super intelligent machines and all these cars on the road. We're working on it, but that's why we're working on a lot of vertical stacks and vertical solutions for autonomous driving, for different industries, for media, finance, healthcare. I think we're entering a space and the future will be fairly fragmented into the problems you're solving are going to drive a lot of the things that you need on hardware and software. And most people would want to have a full solution. They would not want components of it and worry about how to deploy that for their business. And I believe this is where Intel really can help the broader ecosystem and industry by offering these types of system approaches.
Yeah, I totally agree with you. And in terms of the cloud, what role does the cloud play in the deep learning powered future that we're careening towards?
Well, like everything else, this is a complex question. I'm of the growth mindset, so as opposed to scarcity, right? So personally, I think the domain is fairly large and it offers a lot of opportunities and possibilities for multiple players. And I think the cloud is as a tool to deploy and test algorithms and see the value. We do a lot of pilots and proofs of concept on the Intel Nirvana cloud, and people can see benchmarks of different hardware as well and realize the value that comes from deep neural networks. And then that allows the possibility to scale either on our cloud or on other cloud platforms, or even decide they want a data privacy kind of super protected solution for local compute, local training, local inferencing. And we have an appliance for that, which provides all the capabilities and the software tools of deep learning from the cloud to a local deployment. So once again, I think it will depend on the customer, on what problems they're solving, on either legal or other concerns around data privacy, sharing data across borders, especially in Europe. So there'll be a lot of scenarios in which one solution for one customer would not be the right one for another.
I'm totally with you on the growth mindset of cloud providers, and I think what you're referring to there is just that the world of the cloud is not winner take all or even close to that. And like, I did a bunch of shows about cloud providers in the last couple of years, and I did shows where I would ask people like, okay, how does Google, Amazon, Microsoft, DigitalOcean, how do these things match up to one another? And it wasn't like it wasn't like, oh, you're comparing the Honda Civic to the Honda Accord. It's like comparing a bicycle to a car. Like a bicycle is not better than a car; it's just a different vehicle. And these different cloud providers have different advantages, both in how the company culture is structured, the services that they know how to offer, the UI, the developer ergonomics. All of these different things are axes. The economics, of course. All of these different things are axes on which people can differentiate. And by the way, oftentimes a customer is buying in at a price that will be driven down over time, at least on the supply side. So if you're a cloud provider, you can offer a price to a customer and you might be able to get the costs down and eventually work up to a margin today. So the economics can be really good over time. I would love to know if, I don't know, I'm not sure to what degree you can talk about this, but where Intel is looking to differentiate, or from a business point of view. Intel's got this pre-existing manufacturing pipeline of chips that's totally differentiated. How can you leverage that? What are the business opportunities, or what can you talk about at least?
Well, at a higher level, I mean, Intel has a very strong customer base, right? And a lot of the, as I said, focus still, the mind share is on the data center, and that's the more data intense. And then edge is very power sensitive. So the large customer base that Intel has is a very strong Intel ecosystem. And keeping up with being objective here, we're offering deep learning as part of that large engineering system, and we want to enable the customers who are solving problems that are better served by specific deep learning solutions. But we're not losing sight of there's lots of classic machine learning still deployed. There's lots of other work happening in different areas that we want to continue to be part of that system and offer value to the customers. And I think the specifics around cloud and pricing and differentiation, as I stated earlier in our conversation, it's still pretty early in this space, and I'm a strong believer in that growth opportunity. So we'll find a way to monetize. If we're providing value, then I think that will continue to be the case.
Totally. Now, you mentioned the difference between the edge and the data center and the user's device, and you had some discussion of this in your AI Berlin presentation as well, and I found this diagram really useful, where you describe this feedback loop. So you have model training in the cloud, and then you have the program that's able to take advantage of that model. Like on my phone, for example, if we're talking about like Netflix's recommendation system, for example. Like the model gets trained in the cloud, and then on my phone, I'm able to take advantage of that model, and the real world engaging with that model itself is me. That's kind of the feedback loop that goes back into the model training. Maybe you could describe this feedback loop in your own words between these three elements: the cloud and the model on the program, and then how the real world engages with that program.
Well, Jeff, this is the most exciting area, I think, for future developments, in my opinion, at least. And personally, my team is driving to look at some of those emerging solutions. Let me just make it clear, this is not solved. I'm expecting to see a lot of innovation. We're just starting to deploy some deep reinforcement learning. We talked about it earlier. This is where today still most of the deep learning solutions are so-called offline, right? You train on your data on your cloud, and then you deploy. And if you want to update your deep neural networks, then you have to start from scratch. There is no really good feedback loop that exists. And what you're referring to is this emerging space with deep reinforcement learning, where you could have feedback either from your environment, say with robotics and other intelligent autonomous machines. I mentioned a lot of autonomous driving is taking advantage of these new algorithms, but also everything online. I think Google, Facebook, Apple, they're doing very well in incorporating reinforcement learning into the user feedback, whether it's for newsfeed or for local device type of modifications to keep up with data privacy, right? And I think we're still to uncover a lot of new algorithms that will help us incorporate that feedback within differential privacy, without sharing data that we don't want to share to the cloud, but without losing the advantage of a global cloud model that gets updated with the local either user preferences or data available at a local information loop. And that is a lot of research happening here. That is a really exciting area. I think that will help us commercialize more of the AI algorithms in the next few years, and really see quite valuable applications to truly maintain user privacy and deliver results that could be then quite quantifiably useful.
Who do you use for log management? I want to tell you about Scalar, the first purpose-built log management tool on the market. Most tools on the market utilize text indexing search, and this is great for indexing a book, for example. But if you want to search logs at scale, fast, it breaks down. Scalar built their own database from scratch, and the system is fast. Most of the searches take less than a second. In fact, 99% of the queries execute in less than a second. That's why companies like OkCupid and Giphy and Career Builder use Scalar to build their log management systems. You can try it today, free, for 90 days if you go to the promo URL, which is softwareengineeringdaily.com/scalar. SCALYR. That's softwareengineeringdaily.com/scalar. Scalar was built by one of the founders of Writely, which is the company that became Google Docs. And if you know anything about Google Docs history, it was quite transformational when the product came out. This was a consumer-grade UI product that solved many distributed systems problems and had great scalability, which is why it turned into Google Docs. And so the founder of Writely is now turning his focus to log management. And it has the consumer-grade UI. It has the scalability that you would expect from somebody who built Google Docs. And you can use Scalar to monitor key metrics. You can use it to trigger alerts. It's got integration with PagerDuty. And it's really easy to use. It's really lightning fast. And you can get a free 90-day trial by signing up at softwareengineeringdaily.com/SCALYR. softwareengineeringdaily.com/scalar. And I really recommend trying it out. I've heard from multiple companies on the show that they use Scalar, and it's been a real differentiator for them. So check out Scalar, and thanks to Scalar for being a new sponsor of Software Engineering Daily. I did this show with a venture capitalist recently who had written about the aspects of machine learning that should take place in a data center versus at the edge. So, if I'm inside my house on my augmented reality headset and there's a drone flying around outside, and then there's a data center 3 miles from my house, and then there's a self-driving car fleet that's, down on the street near my apartment. Here we've got 4 different areas of computer, and, a drone is going to have some spare compute cycles. A self-driving car is going to have some spare compute cycles. The data center obviously is an endless amount of compute available. It creates this very interesting gradient of different areas where there's different volumes of compute available. And you can imagine a world where these different, edge devices, if you're talking about a drone or a self-driving car or even your smartphone's probably got some spare cycles, definitely has some spare cycles. How does processing from these different areas get distributed or aggregated, or what are the different phases or portions of the deep learning cycle that take place in these different edge environments? And I realize this is totally speculative, but I would just love to get your thoughts on it.
Well, I think that's a future that Intel, of course, would love, right? Lots of compute, lots of data, massive demands and coordination required. So that's a great future for Intel. At the same time, we're still in the early stages of 5G infrastructure, right? Massive data uploads and downloads capabilities. We are having a hard time getting a smart kind of house or smart grid on the same standards and coordinated across multiple devices. So I think the whole world and the high-tech community needs to do quite a bit of work to get all of that seamlessly done and coordinated. But it will probably happen. I have faith in the giants of the world trying to solve these problems. I think within all of it, it continues to be important that we maintain the data that shouldn't be shared in a very private, local manner. And then we benefit from the anonymized data and from these global models in the right way.
Hmm. Right. Okay. So I've, sort of thrown out a very far-flung future, but there's obviously a lot of different things that we could explore between that far-flung future and the way that deep learning proceeds today. And we've already framed it in terms of this feedback loop, this model training in the cloud, the program that's able to take advantage of the model that's sitting on your phone, and then the real world that's engaging with that program, these three different areas of the feedback loop. What's changing in that feedback loop? What are the market forces that are putting pressures on different areas of that feedback loop or giving opportunities to drive efficiency in the different areas of that feedback loop?
Well, first and foremost, we need to solve that algorithmically, right? There is no standard way today to keep updating your deep neural network with new information without retraining the whole network. And so I think this is going to be, because there's real value in terms of market forces, there's need due to privacy, there's need due to connectivity or compute demands or demands on real value at the edge. There's a need to solve this problem, and we don't have a great solution today. So I think once we're able to work in a global model between the cloud and the edge and updating the neural network without retraining everything, then the opportunities will open up to get smarter and smarter, get more personalization, get more controls in that feedback loop of what data is shareable and what is not. And I think across the board, all the drivers of the ecosystem are going to impact how we move forward. But as a general, I think, statement, we're very far away from this artificial general intelligence that people worry about. And I think we have a lot of opportunity to do great narrow vertical intelligence with solutions that help solve certain problems, as opposed to anticipate this kind of omnipresent AI that's going to take over.
Well, since you opened that area of conversation, I'd love to explore it a little bit.
Oh, did I kick the hornet's nest?
Well, it's not a hornet's nest from my point of view. I'm just always intrigued to hear different people's opinions on it, because it's one of these. I mean, it's almost like a religious level question in our industry these days, where you just have like such sharp disagreements, and luckily, it doesn't really drive any policies today, but it does seem like almost like an ideological question. Like, who are the people who are worried? There's like, okay, the people who are worried on one side that this is like a waste of time. Why are people thinking about artificial general intelligence being a threat to humanity? This is like worrying about overpopulation on Mars. That's a quote from Andrew Ng. On the other hand, there's the Nick Bostrom argument that if you make a paperclip maximizer and power it with deep learning, and it figures that the best way to maximize the number of paperclips in the world is to turn all the humans into paperclips, that would be a problematic artificial intelligence. So I guess it sounds like you fall into the former camp.
Most definitely, yes. I think humans, of course, are known to be emotional species, and a lot of that discussion is a little more emotional than rational. And I think objectively, maybe if you're deep into the hyperparameter optimization and the challenges of creating a composite neural network to solve one specific problem, that gives you a somber feeling of how limited we are still. But I definitely think we can. These are all tools, and they're different tools for different purposes. And I think perhaps if one day we discover with perfect precision and accuracy how the human brain works, and we create a human brain and we're able to model that, then maybe we'll have to worry about the artificial brain that we've created. But similar to neuroscience and AI, there's so much we don't know, and I think we have opportunity to just harness the areas that can benefit us, and just worry about solving problems that would help us going forward. And I think there are a lot of great areas about that, like areas in healthcare and other types of industries where humans really will benefit from having more artificial intelligence helping their lives.
I sympathize with that point of view. However, today, okay, the hyperparameter tuning we're doing is figuring out how to better resolve a convolutional neural network that's looking at cat photos, and we're trying to get it better at identifying cat photos. But you can very much imagine a future where we move beyond that. And if you imagine today as the assembly language of deep learning, evolutionarily speaking, and we have people who are programming assembly, in 10 years, most people are not going to be programming assembly. They're going to be programming something that's at a much higher level, perhaps programming a deep learning system to do hyperparameter optimization of robots that are managing a paperclip factory. And maybe, the inputs are you just put a bunch of buckets of chemicals, you put some machinery in this factory, and you just say, okay, deep learning system, have at it. And, here's the different things you're tuning. And, if it just starts tuning this factory where it's just like a bunch of high level variables, then, maybe you could see the paperclip outcome.
Well, it exists in every science fiction production, right? Books and movies. I don't disagree. But again, I have faith in humanity that we're designing this, right? We're defining the policies. And clearly some odd things could happen. We've seen that with training some rogue bots and things like that. But it's a human error. It's not an artificial intelligence out of control. And humans have done all kinds of horrible things to the planet. So we won't get into more global problems, but I still want to maintain, if the right people are involved in designing and developing all of these systems, then we should be able to control them.
So you see this more as like the same questions that genetic engineers are looking at, and they really are in control. And certainly a genetic engineer with bad intentions could develop some horrific virus and cause a pandemic or an epidemic. And similarly, your reasoning that we are still going to for a long time in the foreseeable future, we're going to maintain control of these systems, and we need to treat them as human systems where we need to train the proper human ethic into people. Am I accurately depicting your views?
Absolutely. And you can look at historically kind of tribal behaviors, or just some horrible things that humans have done to other humans, or raising children in a terrible way. I mean, we define what happens, right? It's all about the human influence. So it would be no different.
I want to conclude by just talking about where Intel is at business-wise and deep learning-wise, particularly with regard to acquisition. So Intel has made 3 or 4, at least like high-profile acquisitions that I know of recently. There was Nirvana, which is a sponsor of Software Engineering Daily, Intel Nirvana. There was Mobileye, and I think there was one other. I don't remember what it was. I'm sure there were some other ones. Do you have any perspective for what makes a good acquisition, or what motivates the acquisitions Intel is making? I'd just love to spur some conversation around acquisitions.
Certainly. I think you were missing the Movidius, which was also a pretty large acquisition we did. And I work with Intel Capital regularly to influence decisions on investments in certain strategic areas. Most of the time, and so this is beyond Intel, but globally, acquisitions are very challenging. The value drivers are very challenging. It's a very a complex system and not often extremely successful. But I think for Intel, one aspect of acquisitions that I see working well is that the companies are left fairly autonomously, or as in the case of Intel Nirvana, this is now our AI group and the foundation of what Intel does in AI. And the acquisitions have to be strategic. There has to be an alignment, and the culture, of course, needs to work. And I think that continues to be the case for a large company. Organic growth is very hard. So there's always on the lookout of solutions, tools, customer base, things that are unique, things that are strategically important and valuable. And I think that is more or less important for any company, not only Intel, and for any acquisition to be successful.
All right. Well, I guess since we've just got a little tiny bit more time, maybe you could talk about one area of industry that you see AI impacting today. Perhaps if there's a domain that you find interesting that you think people don't know about, and maybe you could give an application for how AI is affecting it.
Wow, it's hard to think of an area that people don't know about. This is such a hot topic. There has been so much discussion about almost any industry. What my team is looking at in terms of these emerging solutions of how do you deploy deep reinforcement learning into an overall feedback loop of product recommendations, decisions, even kind of product, not only on the consumer level, but on actual enterprise level, product roadmaps. Retail is a great area. I think AI is helping a lot of various kind of aspects of retail, from merchandising to product recommendations. Anything that has this consumer feedback with deep reinforcement learning, I think we'll see more and more value there. Of course, healthcare, it's a little longer term and probably more complex from regulatory and privacy and legal aspects. But I would love to get to a place where with age, we have some AI agents observing behavior and kind of anticipating potentially some health issues before you decide to go to the doctor and before it's too late or something has happened. So I think healthcare will be tremendously valuable for humans. Other aspects of smart cities and IoT are very interesting. Of course, we're just starting to see augmented reality examples really taking a little more mass scale with different applications. So there'll be a lot of, I think, valuable and exciting things that AI helps. But again, they're driven by what we're trying to do, problems we're solving, or how do we benefit from these tools, and not just for the sake of experimentation or tweaking percentages of improvements of model performance.
Okay, Milena, it's been great talking to you, and it sounds like you've got a lot of interesting work ahead of you. So I'm looking forward to seeing the progress that Intel makes on the deep learning front and all of the other businesses that the company's involved in.
Thank you, Jeff. It was a pleasure. Certainly a very interesting conversation, and it's a super exciting space. So let's see what we come up with. I'm sure we'll be talking soon.
Absolutely. We're trying out something new with the Software Engineering Daily question of the week. This week we want to know, what is the best continuous delivery or continuous integration tool, open source tool or platform, some software as a service that you use? We want to know what is the best continuous delivery tool and why you're using it. Send me an email, jeff@softwareengineeringdaily.com. We're going to evaluate the answers, and we will select a random person who emails us and award that person with a free Software Engineering Daily hoodie sweatshirt that we will send you. And then we will compile those answers. We'll get you a write-up in a month or so with the feedback for what is the best tool. So send me an email, jeff@softwareengineeringdaily.com. We would love to hear what you think about continuous integration and continuous delivery tools.
Wow.